Welcome guys to our YouTube channel Education Center. Today we are going to study chemistry of class 9th ICSE. Chapter name is periodic table. Topics to be learned with concentration, that is Tobin's triads, Newland's law of octaves, Mendeleev's contributions, and modern periodic table groups and periods. Tobin's triads. Tobin's triads was like this. He created a group which he named as a triad. In that group, only 3 elements were allowed. At least 3 elements were compulsory, and that middle element was the arithmetic mean of the other 2 elements, or average mean of other 2 elements. Like just have a look on this. Lithium's atomic weight is 7, sodium's atomic weight is 23, and potassium's atomic weight is 39. Okay, now the mean of them is 7 plus 39, which is 46 upon 2, that is 23, right? And then comes beryllium, magnesium, calcium, again that method, and the answer comes 24, and the 24 is whose weight? Magnesium, right? Now there were some defects of triad classification. A large number of similar elements could not be grouped into triads. Example, iron, manganese, nickel, cobalt, zinc, copper are similar elements but could not be placed in the triads. See, this is a periodic table, and in this only some of the elements were created in a triad, but not all. So that was a big mistake done by the Tobin. And then comes the Newland's law of octaves. Newland arranged the elements on the basis of the increasing order of the atomic weight. Okay, in increasing order of the atomic weight. Then just a second. Elements in the increasing order of the atomic weight. He said that elements were arranged in increasing order of the atomic weights show resemblance in physical and chemical properties between 8th element and the first element. Means he told that if this is the first element, 2, 3, 4, 5, 6, 7, 8. Now these are the 8 elements. Okay. Now this first element will show resemblance with this element. Now if there is more element, this will show resemblance with this element. This will show resemblance with this element. This with this, this with this, right? Continue, etc. is going on. Yes. So this continues. Now afterward that just a second, I will have to use the blackboard. So here's an example. Lithium was presented as the first element, then beryllium, okay, then beryllium, then boron, carbon, nitrogen, oxygen, and then fluorine. Okay, then down comes sodium, magnesium, aluminium, silicon, phosphorus, sulfur chlorine. Okay, now this will show resemblance with this because this is 1 2, this is 1 2 3 4 5 6 7 8. Now this will show with this and so on. Okay, now there were some defects in this also. The eighth element from lithium is sodium and from fluorine is chlorine, which shows similarity in properties. Now this method showed grouping and failed. This worked to this worked to this method was worked with some of the elements but not with all. So this method failed. Now the second defect was method of classification and showed meaning with light metals and but failed with the heavy metals. It was not applicable for the heavy metals. It was only applicable to with light metals. Now we will go to Mendeleev's contribution. Okay. Now Mendeleev told that arrangement of elements having similar properties appears at regular intervals, like this is hydrogen, this is lithium, this is sodium. Now see, this were in a regular interval. Here comes beryllium, here comes magnesium, here comes boron, here comes aluminium, then carbon, silicon, nitrogen, phosphorus, oxygen, fluorine, then sulfur, chlorine. Okay, so now over here, see at the regular intervals, this way came, right? Now see the valence electron of this way 1, valence electron of this way 2, and this continued. Okay, so now this continued and then we will go to the next. Okay, now his periodic law was the physical and chemical properties of elements are periodic functions of the atomic weights. Means what? The physical and chemical properties of elements are periodic function of the atomic weights, right? Now see the hydrogen was now see this was hydrogen, this was lithium, and this was sodium, right? So in this, the physical and chemical properties of elements, the periodic function of the atomic weight, right? Its valence electron was 1. It's also is 1. It's also is 1, right? Just continue. And why was this? Because they were coming in the regular intervals, right? Now see, what were his contributions, right? We should know also that also, right? Now his contributions were that he arranged the elements in increasing order of the atomic weight in horizontal rows called periods and in vertical columns called groups. Okay, in vertical columns called groups. Now this red was known as groups and this black was known as periods. Okay, then Elements which are similar with respect to their chemical properties are grouped together and have atomic weights of nearly the same value. Now, as I told that hydrogen, lithium, and sodium were having similar properties, right? It was also having one electron in the valence shell. Same with this and same with this also, right? That's, that is only till in the second point. Elements in the same group had same valence and similar chemical properties. Based on the periodicity of properties, a number of gaps were left in the table for undiscovered elements, that is, elements not discovered. Example: scandium, gallium, and germanium, originally called eka-boron, eka-aluminium, and eka-silicon respectively. The properties of elements, undiscovered elements left in the vacant gaps were predicted. Incorrected atomic weights of some of the arranged elements were corrected with knowledge of the atomic weights of the adjacent elements. Now there were also some defects in his theory. He was not able to place isotopes. He was not able to place earth, rare earth metals. Was not able to anomalous pair of elements, means for certain pair of elements having higher atomic weight have been given position before element having low atomic weight. This defect disappears if the elements was arranged according to their atomic weight. Now I'll give you the example of that. So what happened that he put it cobalt, and after the cobalt, nickel he put it. Now cobalt weight was 58.9 and nickel weight was 58.6. Okay, and cobalt atomic number was 27 and that is 28. So the people began to ask that why did he did this? Why did he put it 58.9 element before than the smaller one? How this can be possible? This was the anomalous pair of elements. Okay. Now we will go to the next topic, which is our what? Correct. We are going to our next topic, which is modern periodic law. Now first we will study about Moseley's contributions. Okay. He created a modern periodic table. Okay. He in his modern periodic table, he arranged the elements according to the atomic numbers, but not by the atomic weights. And yes, there he succeeded. And his modern periodic table is now officially used in the chemistry, right? Now, some salient features of modern periodic table were the arrangement and periods and groups. Okay. Now I am going to tell you about periods. Okay, in the modern periodic table. Now there were basically 7 periods: 1, 2, 3, 4, 5, 6, 7. Okay. Now each period contains one shell. Now it depends on the number of that period. If the period is 1, then the number of shell will be also 1. One shell will be there. In period number 2, 2 shells. In period number 3, 3 shells. Period number 4, 4 shells, and so on. Okay, now in period number 1 only 2 elements are there. In period number 2, 8 elements are there. Period number 3, 8 elements are there. Period number 4, 18 elements are there. Period number 5, 18 elements are there. And in period number 6, 32 elements are there. In period number 7 also 32 elements are there. Okay, so now I will tell you about um, groups. Okay, but before we go deep with the groups, I want to tell you the about this block. In this block, for suppose there is an element called oxygen, its name will be written over here, which is oxygen. Okay, its atomic weight will be written over here, which is 16. Over here its atomic number will be written. Okay, now in some periodic table, the actual atomic weight is also written over here, it is written. Okay, but basically in our in our in our periodic table, which is of 9th standard periodic table, as it is a basic periodic table, so in that there is no need of actual atomic weight, so it is not given over there. Okay, now in periodic table there are only 18 groups. Okay, there are only 18 groups. In the group 1 only, in the group 1 they are having one valence electron. In group number 2 they are having two valence electron. In group number 3 they are having in group number 3 to group number 12 they are having two valence electron, as there are transition elements. Okay, now I'm going to teach you how to make a periodic table. Okay, will that be okay? I know you will be proud to learn that, right? Now see, we are going to make a periodic table, so I'm ready with my pen. Let's begin. Now I will make a periodic table. See, 1, 2, 3, 4, 5. See over here, I have made 18 groups. Now I'm going to make 7 periods. 1, 2, 3, 4, 5, and yes, we succeed in making the structure of our periodic table. Yes, we have made our 7 periodic tables periods. Okay, now you have to listen me very carefully. Okay, okay, I'm going to use this yellow highlighter to name the alkali metals. Okay, now I'm going to show you the alkali metals. Now the alkali metals are in group number 1 in period number 2 to 7. Now this is our group 1, 2 to 7. See. Now here our alkali metals are there. Now our alkaline earth metals are in group 2, same 2 to 7. Okay. Now our transition, wait, I'll just label over here. Now this is our alkali metal. This is our alkaline earth metal. Okay. Hmm. Now I'm again using highlighter green to show you about transition metal. Okay. Now transition metal are in from group number 3 to 12. 4, 5, 6 in period number 4, 5, 6. Okay. Group number 3 to 12. 1, 2, 3, 4. 1, 2. Just a second. These are our transition earth metals. Okay. Our transition earth metal. Now I will write over here. Transition earth metal. Now this red color is our inner transition metal. No. Transition metal. Now see, just have a look on this. We made our periodic table. Okay. Now see, this green line represent, see this green line represent our noble gases. Okay. And this blue color represent post transition metals. This yellow color represent alkali metals. This blue color highlighter, light blue color highlighter represent alkaline earth metals. Red color highlighter represent inner transition metals. Green color represent transition metals. Okay. Now this pink color represent halogens. Okay. Now the spaces which I'm coloring orange. Okay. The spaces which I'm coloring orange are the other non-metals. Okay, these are the simple non-metals. Okay. Now henceforth we created our periodic table. Congratulations to all. Congratulations, we created our periodic table without any book, right? You just have to learn this table Okay. Just a second. So I was telling that. Now just have a look on this. This blue are post-transition metals, orange are other non-metals, yellow is alkaline metals, light blue is alkaline earth metals, pink is halogens, dark green is inert gases or noble gases, red color is inert transition metal, and green color is transition metal. Okay, periodic our structure of making periodic table is over now. Okay, now we have completed our chapter. So I am giving you some question in the assignment. Okay, so name the elements in period 1. Yes, the answer is hydrogen and helium. What is the common feature of the electronic configuration of element at the end of period 2 and period number 3? If you want to listen the question again, just rewind this. The answer is the at the end the 28 or 288 is the configuration. Okay, what are elements? Elements are the pure substances made up of pure what? Yes, elements are the pure substances made up of only one kind of atom. Okay, how did early chemists classify elements? Yes, they classified elements on the basis of their character, nature, or properties, like we classify air, water, fire, earth, etc. Okay, now um now we will meet in the next video. Have a nice day. Goodbye. Take care. Bye bye. In next video I will be teaching you geography chapter, which is feathering. Okay, bye bye, take care.